So what we have here is three special types of parallelograms, and they have all of the features of normal parallelogram plus some extra features that we're going to learn about today. Rhombus, all four sides are congruent. We already know that in a parallelogram, opposite sides are congruent. As it turns out, in a rhombus, all of them are. Okay. A rectangle, we have all four angles 90 degrees. We know in a parallelogram, opposite angles are congruent and adjacent or consecutive angles are supplementary. This is also true for this case, but they just all happen to be 90. Now, a square has all four sides congruent and all four right angles. Essentially, that is both a square is both a rhombus and a rectangle. So what you see here in this Venn diagram is of these special parallelograms, we have rhombuses here, we have rectangles here, and their overlap is squares. So is this parallelogram, ABCD, a rhombus, a rectangle, or a square? Square, ABCD. Okay. We're already told that it's a parallelogram. We know that it has the features of a parallelogram, which is helpful because we can then use that to find out other information. And very specifically, how do we decide? Well, we have to look at the definition of rhombus, rectangle, and square. Remember, rhombuses have all four sides congruent, rectangles have all four angles 90 degrees, and a square is both. So, what is it? It's a rectangle. Let's trace it out. Parallelogram ABCD. We know that in a parallelogram, we have consecutive angles summing to 180. So if this is 90, this must also be 90, and this must also be 90. We also know that opposite angles are congruent, so that's got to be 90 as well. We have all four angles 90 degrees. Okay. We don't know about their side lengths. We can't say that all four are the same, so we can't continue to further classify it as a square. We don't know that, so we know it's a rectangle. Give this got it problem a try. Is parallelogram EFGH a rhombus, a rectangle, or a square? And explain how you know. Okay, here we have two theorems that are related to rhombi or rhombuses. If a parallelogram is a rhombus, then the diagonals are perpendicular. You're always going to get 90-degree angles when you draw the diagonals. That's one of the theorems. The other one is that if a parallelogram is a rhombus, then we know that the diagonals are bisecting the opposite angles. And since in every parallelogram opposite angles are congruent, then if we bisect these congruent angles, we're going to get 1, 2, 3, 4 angles that are all equal in measure. So angle 1 is congruent to angle 2, is congruent to angle 6, is congruent to angle 5, all the red ones. Same thing here. We know that opposite angles in a parallelogram are congruent. So if the parallelogram is a rhombus, then those angles are bisected, giving two identical angles bisected, 4 angles total. Right? All the blue angles are equal measure. We can apply those theorems now to find the angles here. Let's do that. What we've got here is this problem. What are the measures of the numbered angles? Okay. Well, we know, as we said from the last theorems, that we've got the same angle here and here, and here and here. We also know that we always get 90-degree angles here, and since this is a right triangle, and this is 90, this angle and this angle need to sum to 90, so we can calculate what 4 is. So, in total here, how are the numbered angles formed? They're formed by diagonals, and so we use what we know about diagonals in a rhombus. Okay, we already know that the measure of angle 1 is 90 because that is always what's formed when you have the diagonals of a rhombus. Okay, measure of angle 2, they say now alternate interior angles are congruent. That's true. If BD is the transversal because we know these two opposite sides are parallel. That's what a parallelogram states. Then we know this and this are congruent, and that's 58 as well. We also know that this angle is bisected, so 3 must be 58 as well. Okay, but you also know this just generally, that this angle, this angle, this angle, and this angle will always be the same in a rhombus. Okay. Now in this triangle, we know that angle 1, 4, and 3 must sum to 180. We know what 2 of them are, so we can then calculate the remaining angle for 4, and it is 32. So give this got it problem a go and see how you do. Here we are moving on to rectangles, and the diagonals of a rectangle also have a special property. Very specifically, if you know it's a rectangle, and you need to establish that it's a rectangle first, right? You can't just jump right in. We need to show that we have enough information to say that it's a rectangle, or they might just tell us. Then, what do we know? When you draw the diagonals, those diagonals will be congruent, equal in length, okay? And extending that idea, we also know that in a parallelogram, the diagonals bisect each other. So that means that there's 2 equal lengths being bisected, and we're going to get 1, 2, 3, 4 segments, all of equal length, right? From the vertices to the center. 1, 2, 3, 4, all the same length. Keep that in mind. Now in this rectangle here, we've got the diagonal SF, an algebraic expression for its length at 2x plus 15, and the length for the diagonal of RB is 5x minus 12. What is the length of a diagonal? And we have these possible choices. Well, remember, diagonals are congruent in a rectangle, and they told us that's what it is, so we can set those algebraic expressions equal to each other. So, yep, we can write it as an equation is what this is suggesting. And here you go. We set them equal to each other. We find that x is 9. That's not what they're asking for. They're not asking for the value of x. So don't mark 9 as your answer, because we need to plug that back in, and we need to check what is the length of a diagonal. Now, they plugged it into 5x minus 12, and they got 33. But you should also plug the same value, 9, into the other expression too. 9 times 2 is 18. 18 plus 15 is 33. When you do that, you're verifying that the value of x was correct, because it wouldn't work out to be the same for both of those expressions unless you came up with the correct value of x. So do check it in both to make sure that you're coming up with the same number. Why don't you give it a go with this got it problem? This diagonal LN is, its length is described as 4x minus 17, and the length of this diagonal MO is described as 2x plus 13. What are the lengths of the diagonals? Also, what type of triangle is this? Triangle PMN right here. Okay. Try these out and restart when you have an answer. Okay, so we know that because they are the diagonals of a rectangle, they told us that it's a rectangle here. We can set those amounts equal to each other. So 4x minus 17 equals 2x plus 13. You should know how to do this algebra. And when you juggle this around and you solve for it, you get x equals 15. That is not the answer. You need to plug it back in. And what I'm going to suggest is that since we're trying to find the length, and this describes the length of one diagonal, and this describes the length of the other diagonal, and they're supposed to be the same, you can plug that in, 15 in for both, and essentially plug it into this equation here, and verify that you're getting the same number on both sides, and that number that you do get on both sides will be the length of the diagonal, since each side describes the diagonal's length. So what do we get? 60 minus 17 equals 30 plus 13. That's 43. 60 minus 10 is 50. 50 minus 7 is 43. 43 equals 43. Check. Okay. And the last bit, what type of triangle is that? Well, we know that the diagonals are bisected, and since both diagonals are the same, or they're congruent rather, then that equals that, and that means that it is an isosceles triangle. Give these lesson check problems a go and restart when you have your answers written down so you can check and see if you're on the right track. Good luck with this.